Threat modeling can be understood as making sense of the complexity of the system we have at hand, whether it's a mobile application, web application, or even a network, and then by identifying all the possible threats it might face, and then by assessing those threats. In simple terms, it's about finding different ways in which our system can be attacked and subsequently designing countermeasures to stop these attacks. Threat modeling helps us become more proactive and strategic in our operational and application security. The ultimate goal is to reduce the attack surface and focus on the investment of the business itself. It actually starts by a couple of questions. What are we working on? So we have to identify the assets, and then what can go wrong? So after identification of the assets and having the architectural overview of the system, we ask ourselves many questions. How can the system be attacked? What can go wrong? So we need to pinpoint those questions. After that, what can we or what are we going to do about it? So here we start thinking of the countermeasures and the controls we will have in place. And at the end, we need to assess our job. Did we do a good job? Threat modeling actually springs from the trivial risk assessment model. We need to identify threats in the first place, whether it's a process, it's a software, it's an attacker, anything can be a threat. The threat can attack our systems by taking advantage of weaknesses we have or vulnerabilities we have, and the purpose of threat modeling is to close the gaps of these vulnerabilities, is to put controls in order to close those vulnerabilities. So why threat modeling? Here are some of the benefits of threat modeling. It helps us identify and investigate potential threats to our system. It helps us understand our vulnerabilities. It helps us identify the logic between our system, how data flows, how instruction flow. It helps us create a set of standard documents that can be used to create specifications. So it's about systems and documenting the workflows and understanding our systems better. It helps us eventually in reducing the attack surface, reducing the threats, and closing and fixing many of our vulnerabilities. And of course, it helps us define the overall security posture of a system or an application. Different methods and techniques are used by pen testers, by practitioners, by analysts to understand the variety of information security risks. Some of those structured threat modeling techniques are attack trees, stride method, elevation of privileges, TMAP, PetriNet, data flow diagram, activity diagram, and risk reduction overview. Some of the most famous models is the stride model. So after having the architecture overview or after simplifying our process or system and projecting it on a diagram, we start thinking about what can go wrong. How does this web application or a mobile application workflow goes? Do I care about what can go wrong with this application, for example? Does it have financial information? How about the content of where is the data stored, etc. So we spend much of time in analyzing each of the steps in our architectural overview, and one of the simplest techniques that can help us is the stride. Stride is a mnemonic for spoofing, tampering, repudiation, denial of service, and elevation of privilege. The technique is used for identifying threats in these 6 areas. It's actually another taxonomy for the famous triad, the CIA, the confidentiality, integrity, and availability. So the ultimate goal of stride is to go through the process and start asking ourselves, how can someone spoof his identity? How can someone tamper our data? And how can we make sure that there is no repudiation in place? How can information be disclosed, and how can someone take advantage of some vulnerabilities to provide a denial of service? And how can someone access the system in an unauthorized way? And many mitigation approaches exist, such as using passwords, multi-factor authentication, and digital signatures to protect against spoofing attacks. And we can use permissions, access control lists, and again, digital signatures to protect against data tampering. We can use secure logging, auditing, and digital signatures, of course, to protect against repudiation. Encryption, access list controls as well can be implemented to protect against information leakage. Permissions, access controls, quotas, for example, some filtering techniques can be employed to protect against denial of service, and lists to protect against elevation of privileges. We can implement the techniques of input validation and access controls.